Welcome back to my channel. This time we will be solving more problems. Still the algebraic functions, trigonometric functions, and also the transcendental functions. So let's start first with the algebraic functions. Let's have number 1. We have the integral of dx whole over with quantity x minus 5 raised to the power of 2. So we have learned from our previous videos that first thing is that we will try to find the relationship of the numerator and denominator. Now for this example, example number 1, if we look at the denominator, we have the quantity x minus 5 raised to squared. We can select or we can choose for the value of u as x minus 5, and then the derivative of u, the derivative of x, which is dx, the derivative of 5, which is 0. So if you look at the numerator, we have the dx. So we could replace the value for the u and for the value of the du in our problem. So let's have the integral of, this will be our du, whole over with x minus 5, that is u raised to the power of 2. So we now have the integral of du over u squared. We could take the inverse of u squared. We will be having u raised to the power of negative 2 du. Applying power rule, the integral of u raised to the power of negative 2 du, that is equivalent to u raised to the power of negative 2 plus 1 over negative 2 plus 1 plus c. Okay? So we now have u raised to the power of negative 1 over negative 1 plus c. Or we could rewrite this one as negative, since we have a negative, 1 over the u plus c. Again, we have to bring back what is the value of our u. In the beginning, we have the value of u as x minus 5. So we now have our final answer as negative 1 over x minus 5 plus c. This will be our final answer. Now, we will be solving problem number 2. Okay? So, if you look at the integral, we have a fraction. Okay? So, we have u squared for the numerator, and we have also quantity 1 plus y cubed, quantity raised to the power of 2. So, in this type of example, we will be again finding the relationship of the numerator and denominator. Let's try to find if there is a direct derivative from the denominator. So if we choose 1 plus y cubed as our u, 1 plus y cubed, the derivative of our u, the du, that will become, the derivative of 1 is 0, the derivative of y cubed, that is 3y squared dy. Now, checking for the numerator, we have dy, we have y squared, and we only lack 3. So, what we're going to do, as per our previous videos, so we will be correcting our fraction by multiplying with 3 over 3. The integral of y squared dy whole over with quantity 1 plus y cubed raised to the power of 2. We could use the numerator 3 outside, so we will be having 1/3 integral of 3y squared dy whole over with 1 plus y cubed raised to the power of 2. Okay, now we could replace the values of our numerator and denominators. We have 1/3 integral of, this is obviously the du over this one as the u squared. Okay, so we now have 1/3 u raised to the power of negative 2 du. Integrating this one. So we now have 1/3 u raised to the power of negative 2. We have this one, u raised to the power of negative 2, that is u raised to the power of negative 1 over negative 1 plus c, of course. Okay, so we will be having negative 1 over 3u plus c. Okay, it's not yet our final answer. Why? Because we have to substitute the value of u. So therefore, we'll be having negative 1 over 3. What is the u? We have quantity 1 plus y cubed plus c. Now this is our final answer. Now proceeding to problem number 3, we have the integral of quantity y plus 1 over y quantities squared dy. Okay, so in this scenario, if we choose y plus 1 over y as our u, if we derive this one, this is not the derivative of this whole function. Okay, so what we're going to do is we will apply algebra first. We could rewrite this one as the integral of y plus y raised to the power of negative 1 squared dy. Now if we chose this one as the u, deriving this one, this will not be the result. So what shall we do? We will be expanding this one since we have quantity raised to the power of 2. So expanding this one, we have y squared plus 2y times y raised to the power of negative 1 plus y raised to the power of negative 2 dy. Okay. So in algebra, y times y raised to the power of negative 1, that is equal to 1. Okay. So we now have y squared plus 2 plus y raised to the power of negative 2 dy. Distributing the integral symbol and the dy here, we now have y squared dy plus integral of 2 dy plus integral of y raised to the power of negative 2 dy. Okay. So the power rule, and we have the general theorem. So y squared, that will be y cubed over 3. How about this one? 2 could be placed in front of the integral symbol, the integral of dy, that is y. So we now have 2y. And how about this one? Integral of y raised to the power of negative 2 is just like with example number 1 and example number 2. That is equivalent to u raised to the power of negative 1 over negative 1 plus c. Since we are using y, so this is y. Okay? So rewriting, we now have y cubed over 3 plus 2y minus 1 over y plus c. This will be our final answer. Now let's solve problem number 4, the integral of x squared, quantity x squared plus a squared, quantity raised to the power of 2d of x. Now in our previous example, we keep on finding what is the value of our u so that we could replace some algebraic functions. Now in this example for number 4, so if we try to use this function, x squared plus a squared, where a right here is constant. So if we use this function, x squared plus a squared, okay, as the u, deriving that one, that will become 2x dx. Now if you look at problem number 4, if you look at the problem, x squared plus a squared as our u, and its du as 2x dx. We have dx, but we have x squared here, and we only have x here. What shall we do with the extra x? And we need 2. So that is why we can do another solution in solving this one. So not choosing or not letting values for u and du. How about if we're going to expand the quantity squared? So this will become x to the fourth plus 2x squared a squared plus a raised to the power of 4 d of x. Okay, how about that? And from this moment on, we will be distributing x squared to all our terms. So we now have x to the 6 plus 2x to the 4th a squared plus a to the 4x squared, and all are multiplied to dx. So distributing the integral symbol and the dx to all our terms, we now have the integral of x to the 6, the dx. The 2 is a constant, a squared is a constant, integral of x to the 4th dx, plus a to the 4th is a constant, integral of x squared dx. Now we could evaluate all the integrals. Integral of x raised to the power of 6, that is x raised to the power of 7 over 7 plus 2a squared. Integral of x raised to the power of 4, that is x raised to the power of 5 whole over with 5 plus a raised to the power of 4. Integral of x squared, that is x cubed over 3 plus c. So we would now have our final answer as we have 1 over 7 x raised to the power of 7 plus 2a squared whole over with 5 x raised to the power of 5 plus a raised to the power of 4 over 3 x cubed plus c as our final answer. Now solving number 5. Number 5, we have the integral of x, quantity x squared plus 3, quantity raised to the power of 3 d of x. Now if we expand x cubed, it would be possible, just like with number 4. But x cubed is a longer expansion than the x squared. So how about letting x squared plus 3 as our u? So we have x squared plus 3. Deriving the u, we'll be having 2x d of x. We have our dx right here. We have our x right here. We only need 2. Unlike with problem number 4, we will be having extra x right here. So problem number 5, it's easy for us to identify the u and the du. Now we only need 2. So we will be multiplying 2 over 2, integral of x squared plus 3 raised to 3, and we have our x dx. Okay, we only be needing the numerator 2, so we now have 1/2 integral of x squared plus 3 cubed 2x dx. Okay, so now we have 1/2 integral of this one will be replaced as the value for u cube, and this one adds the du. Now we could perform or evaluate. So this is 1/2. What is the integral of u cubed? Du power rule, so that is u to the 4th over 4 plus c. So we'll be having a result of u to the 4 over 2 times 4, we have 8 plus c. Bring back what is the value of u. We now have quantity x squared plus 3 raised to the power of 4 over 8 plus c. Now, next problem, we have number 6, the integral of quantity x raised to the power of 6 minus 7x quantity raised to the power of 4 d of x. Now, let's try to evaluate this one. We are oriented to always find the u for this specific type of problem and find the du, or find its derivative. Now, if we wish to use this one as our u, or select this one as our u, x raised to the power of 6 minus 7x, deriving this one, that is 6x raised to the power of 5 minus 7. That is obviously not found in our original integrand, or our original problem. We don't have 6x raised to the power of 5 minus 7. So how are we going to solve this type of problem? We normally try to use algebraic method first. But what else? What type of algebraic method are we going to use? Shall we expand 4? Now, it is a very long expansion. Now, we will be having another technique. So the technique is, we will be looking at the two terms. What is common to both of the terms? Both terms contain x. We have x raised to the power of 6, and we have x right here. If we factor out x from both terms, now we could use algebraic method to this one. So this will be integral, factoring out x to both of the terms. Let's have x. Here, what's left is x raised to the power of 5 minus 7. And everything is raised to the power of 4 d of x. Now notice in algebra, if we have ab raised to the power of n, this will be distributed to both a and b. So we now have a raised to the power of n, b raised to the power of n. So in this case, we will be distributing the power to each of the two functions. So we have the integral of x raised to the power of 4, x raised to the power of 5 minus 7 raised to the power of 4 d of x. Now notice, we could now choose this one as our u. U as x raised to the power of 5 minus 7. The derivative of u, x raised to the power of 5, that is 5x raised to the power of 4 d of x. So multiplying with 5 over 5, integral of x raised to the power of 5 minus 7 raised to the power of 4. We have here x raised to the power of 4 dx. Writing the numerator 5 inside. So we could now substitute for the values of our u and du. We now have 1 over 5 integral of u raised to the power of 4. And this one is the du. So we now have 1 over 5 u raised to the power of 4. That is u raised to the power of 5 over 5 plus c. Okay. So resulting to u raised to the power of 5 whole over with 25 plus c. The final answer will be, let's have 1 over 25. Our u is x raised to the power of 5 minus 7 raised to the power of 5 plus c. Now this will be our final answer. Now for number 7. The integral of the quantity 1 minus square root of x, quantity raised to the power of 3, whole over with the square root of x d of x. Now, obviously, we will be selecting 1 minus square root of x as our u. So if we select this one, or if we choose this one as the u, 1 minus square root of x, the derivative of our u, The derivative of 1 is 0 minus the derivative of square root of x, that is 1 over 2 square root of x dx. Checking on our original integrand, we have the dx right here. We have the square root of x in the denominator. We need to have negative, and we also need to have 2 on the denominator. So we'll be multiplying this one with negative 2 over negative 2. So we have integral of quantity 1 minus square root of x cubed, and we have 1 over square root of x dx. Writing the denominator 2 inside and also the negative inside. So we now have negative 2 outside. This is the u, obviously. This is the du. Okay, so now have negative 2 integral of u cubed. This one is du. Now, performing the integral or evaluating the integral, we have negative 2 u cubed, that is u to the 4th over 4 plus c. Now 2 over 4, we have 2 for the denominator. The final answer will be negative 1/2 u raised to the power of 4 plus c. Now, bring back what is the value of the u, which is 1 minus square root of x. So we now have negative 1/2 1 minus square root of x raised to the power of 4 plus c. Now, number 8 for our algebraic functions. We have the integral of x raised to the power of 4 plus a raised to the power of 4 all over with x cubed dx. Now a right here is again our constant. So deciding what will be the u. Now if we select this one as the u, x raised to the power of 4 plus a raised to the power of 4, deriving the u, we have 4x cubed dx. We'll be having a problem. Why? Because the dx is right here written at the numerator, but our x squared is written in the denominator. So we will not use this technique, or we will not use this process. Instead, we will be again using algebraic method to this type of example. Okay. So look closely. We have a denominator of x cubed. We could split this one to both our terms for the numerator. This could be written as x raised to the power of 4 over x cubed plus a raised to the power of 4 over x cubed, quantity dx. Now, performing algebra, x to the 4th over x cubed, we will be cancelling this one out. We now have x plus a to the 4, that is our constant. How about x cubed? Rewriting this one using the inverse, we have x raised to the power of negative 3 dx. We could distribute the integral symbol and our dx to each of the term. We now have the integral of x dx plus a to the 4th is constant, a to the 4th, integral of x raised to the power of negative 3 dx. Now we could evaluate the integrals, power rule and power rule. So the integral of x dx, that is x squared over 2 plus a to the 4th. For the x raised to the power of negative 3 plus 1, that is negative 2. And for the denominator, negative 2 as well, plus c. We now have x squared over 2. Since we have negative, so this one is minus a to the 4 over 2, x raised to the power of negative 2 plus c. Okay, this could be our final answer, or we could Again, take the inverse of x raised to the power of negative 2. We now have x squared over 2 minus a to the fourth over 2x squared plus c as our final answer.